Hi guys, how are you? This is Nikhil. In this class, we will start studying about a power plant or a power station which is called as a steam power station. What is a power station? First thing, I have already discussed about that. Just let me again introduce to you. Power station, okay? Power station is a station. What is a station? Station is a combination of some equipments. Okay, so there are some equipments in this station. What is this equipment doing? This station, this combination of equipments is the station. This station will convert any other form of energy in the nature which is directly available in the nature. Some form of energy which is directly available in the nature into finally electrical energy which we require, because that is what our aim is, because energy resources are scattered and different types of energy resources that are available in the nature which are actually useful to us. But the problem associated with such energies is that they are not available whenever you want, and another problem is the transportation problem. All such problems are there. Therefore, we are dealing with a unique energy called as electrical energy. So, we are using an equipment, combination of equipment called as a power station. This fellow, what he will do is, he will convert some form of energy into electrical energy. Okay. So, if that conversion process from some other form of energy to electrical energy involves steam, then it is called as power station, steam power station. This steam power station has got another name, generally called as thermal power station. So we will be using this short form TPS, thermal power station, throughout our discussion. TPS means thermal power station. Why it is called as thermal power station? Because steam is a representation of thermal energy, which is nothing but heat energy. How can you say that? Why? Because what is a steam? Steam is nothing but evaporated water, isn't it? How does water evaporate? When water traps heat, then it will be evaporated into water vapor. That is called as the steam. Therefore, steam is nothing but the representation of thermal energy. So, any power station which involves production of steam in order to create electrical energy, that is called as a steam power station. So, to produce steam in a steam power station, any steam power station, what do we require? What do we require means, we require a device which can produce steam. We are calling it a boiler. Let us say it is a boiler. To this boiler, what we have to give you, as the name itself says, it is a boiler. It requires what? It requires some water. Okay, it requires water, and you also have to supply it with some fuel. Okay, and along with fuel you have to supply with air. Why? Because you want to burn the fuel in the presence of air so that you will get the heating effect, and this boiler has got a furnace where you will supply the fuel and air mixture, and this will heat up the water, and this water will boil, and finally from the boiler you will get steam. So this is how we produce steam in a steam power station. Okay, now the next important thing that we have to consider here is, now in this boiler you are telling that, sir, we require some fuel, you have to burn the fuel. What is the fuel? Understood? What is the fuel? So the point here is the fuel type. So in a steam power station or a thermal power station, the fuel may be coal or it may be oil. So depending upon that particular country's geographical condition or mineral resources, whatever is mostly easily available, that will be the fuel. For example, if you take India, in India we are plenty with coal reserves. So most of the Indian power stations, okay, Indian thermal power stations use coal as input fuel. So this becomes a very important question for competitive exams. In competitive exams, they ask the input fuel for thermal power stations fired in India is coal. It's not oil. In US, it is majority oil. In Middle East countries, depending upon their availability of fuel, that is oil. But India, we are having plenty of coal reserves. Therefore, coal is the input fuel for Indian thermal power stations. Now, when you talk about thermal power stations in Indian context, there is one important aspect or very much important relevance of thermal power station. That is, in India, 67% of power generated from thermal power stations only. So that is the significance of thermal power station. This thing we have already seen. So in the exam, he will ask you how much is the share of power generated from thermal power stations in India. That is 67%, or you may also say 2/3 of total power generated in India is from the thermal power stations only. So okay, now we will see how this production of steam, how this steam will actually help us in creating or converting some form of energy into electrical energy. Now, if you see here, initially what is directly available in the nature? In our discussion now, tell me what is the natural product or natural resource that is available in the nature? That is nothing but the fuel. In India, coal. Okay. Now you are having coal. So my final intention is to convert coal into electrical energy in this thermal power station. So what is that energy present in the coal? Coal has got what? Chemical energy. Okay. The form of energy in coal is chemical energy. Upon heating coal in the boiler, you are getting what? Steam as output. Steam is a representation of what energy I told you? Heat released by the coal, because the heat released by burning of fuel is utilized by the boiler to heat the water and create steam. To the boiler, input energy is chemical energy in the form of coal. Output energy from the boiler is steam, which is also called as thermal or heat energy. Okay, thermal energy is created. Okay, now you see different processes will take place, or a combination of equipment will try to process this energy. Okay, what energy is directly available? Chemical energy in the form of coal is there. So that you are processing in different stages and finally make it into electrical energy. So that is the entire gist of thermal power station. So once you get steam from the boiler, this steam has got certain temperature and some pressure. Okay, when the steam is having pressure means it is moving in the tubes. So with this pressure, what this steam will do is it will strike the blades of a turbine. So there we are having a device called as what? A turbine, steam turbine. What does this steam turbine will do? Let us say a steam turbine is simply like a wheel only. Let us say a wheel, something like this. This is not exactly, but something like this. Let us say I am having a pipe which is carrying steam. Now in this pipe steam is coming and you are releasing the steam, and this steam is striking these blades which are mounted on some rotor. So this fellow starts rotating. Okay, so what is actually turbine is doing? Turbine is converting steam energy or thermal energy into what? Mechanical rotation at the output. Okay, so turbine is an energy processor which will convert thermal energy into mechanical energy. Now once you got mechanical energy, in electrical engineering, what is that device which is actually used to produce electricity or EMF? Generator, isn't it? What is a generator? Generator is a device which takes mechanical as input and provides electrical as output. So the entire drama that actually takes place in any power station is to convert that particular form of energy which is available in the universe to mechanical energy. Once you get mechanical energy, your job is done. Just put a generator, generate electricity, that's it. Understood? So this entire process of production of steam and all is to finally create a mechanical energy or a mechanical rotation. Once you got the mechanical rotation, supply it to the generator and you will get the electrical energy output. So that's the entire formula, or I can say the entire conclusion for thermal power station. So to define technically what is a thermal power station. So defining, it is a PS power station in which heat released by burning of coal is utilized, okay, by the boilers to raise steam at high temperature and pressures, which is used to drive a turbine which is coupled to an electric generator. That's it. So that is the definition of a thermal power station. So this definition itself says everything. So if you look at the exchange of energy, as I told you, according to law of conservation of energy, energy can be neither created nor destroyed. It can just transfer from one system to other system. So here we are having the coal energy or some fuel energy, converting it into electrical energy. Let us see what is actually happening. So if you look at this thermal power station, initially you are having some fuel, hydrocarbons, which is having some chemical energy. Okay, this chemical energy, what I am going to do is I am going to supply this to a device called as what? A boiler. Okay, a boiler, what it is doing, it is providing you output as a steam. What is this steam? Steam is nothing but thermal energy. Understood? Thermal energy. And this thermal energy or steam energy are supplying to some device which is called as what? A turbine. It is a steam turbine. In fact, what is this steam turbine doing? It is taking thermal energy as input and providing you what? A rotation as output, isn't it? Rotation of shaft as output. So this rotation of shaft is nothing but the mechanical energy. And this, what you are doing, you are coupling to a alternator or a generator, and once you get mechanical energy to the generator, what you will get? you will get electrical energy as the output. Understood? So this is how the energy is been exchanged or energy is been processed in a steam power station, or simply I can tell any power station is basically a energy processing setup. So you're having input as a chemical energy, you're processing this in 3 levels. What are the 3 levels? One is at the boiler, you are converting chemical to thermal, and at the turbine you are converting thermal to mechanical, and at the generator you are converting mechanical to electrical. So how many processes are involved here? 3 stages are involved, or 3 processes, or 3 levels of conversion are involved. So whenever energy is been transferred from one system to another, like that there are three systems. So we also know that practically when energy is trying to transfer from one system to other system, not all the total energy will transfer, but a part of that energy will be lost in the form of losses. So more the number of stages of conversion, more will be the losses. Definitely steam power station is the station which is having, I can say, more number of stages of conversion. Therefore more conversion, more losses at each stage. Therefore it will have poor efficiency. And to be frank, the efficiency of this process, okay, the efficiency of this conversion process is around 29 to 32%. Okay, 29 to 32% is the efficiency of a thermal power station. Why? Because there are 3 stages of conversion involved, and when you are asked at which stage, sir, we are getting more losses and which stage, sir, we are getting less losses, and it is that stage, this stage where you are getting more losses. Okay, what you are getting? You are getting more losses in this stage, and where you will get least losses is in the generator, least loss. Now since we are having energy conversion taking place at 3 devices, I can tell that boiler, steam turbine and electric generator are the heart, or I can say the core components or the main components of a thermal power station. Without these 3 things, you cannot construct a thermal power station. Others are your choice. Others are like accessories which will enhance its functionality or will try to improve its efficiency. Understood? So that is a thermal power station, core components of a thermal power station. So at the boiler also you are having some energy conversion from chemical to thermal. Then I can say that we can define an efficiency to a boiler. So boiler efficiency is called as eta B. Okay. And at turbine also you are having some efficiency, eta T. Okay, turbine efficiency is also called as thermal efficiency. This is again forms an important MCQ. He will ask you turbine efficiency also called as thermal efficiency. Why? Because actual thermal energy which is produced according to this title is actually processed by, or is processed by a turbine. Next you are having electric generator. So electric generator will have an efficiency called as, it is having an efficiency eta E. It is also known as alternator efficiency or generator efficiency, or it is also called as electrical efficiency. Okay, and if I talk the level of efficiency, electrical efficiency is highest. This is the highest efficiency. Why? Because losses are less. Here more losses are there. Therefore this is the least efficiency. And the reason for low efficiency of a thermal power station is the low efficiency of, due to the low efficiency of a turbine. Understood? So this efficiency is nothing but the overall efficiency of a thermal power station. And how do we define overall efficiency of a thermal power station? Means overall efficiency of a thermal power station, which is eta O, is given by efficiency of turbine into efficiency of generator. That's it. Okay, you shouldn't consider the efficiency of boiler due to some reasons which is out of scope of our subject, but just be convinced that overall efficiency means we will just consider the more loss component and least loss component, and boiler is not a standardly taken as a efficiency. So overall efficiency will consist of turbine efficiency product electrical efficiency. So some people also say that it will be the product of boiler efficiency into turbine efficiency, electrical efficiency. Yes, this is the correct figure. Actually, by taking boiler efficiency, we will deviate from the actual figure that we are interested in. Why? Because we are having more losses in the turbine, because efficiency of a steam power station mainly revolves around the efficiency of the turbine. Why? Because turbine is the place where more losses is happening, and this is the significant efficiency which is actually trying to reduce the overall efficiency, and electrical efficiency is very high, around 95 to 98%. Therefore, even though you consider electrical efficiency, the overall efficiency figure is not going to disturb. But if you are considering boiler efficiency, whose efficiency varies between 70 to 90%, then this fellow actually will create a significant change in the overall efficiency figure. So due to such factors, we don't consider a boiler efficiency, but we will take overall efficiency is turbine efficiency or thermal efficiency into electrical efficiency. Now I want to explain about some interesting aspect or some important concept associated with thermal power station, which you rarely find in any textbook or any notes. Okay, so the important parts, the three important main parts in the construction of a thermal power station are boiler, a steam turbine and an alternator. This thing we are clear now. Now there are some thermal power station. Now to the boiler, what is the inputs? So in a thermal power station, boiler will have basically three inputs. What are those three inputs? First, to the boiler you have to supply with water. Okay, you have to supply with water. And next, what we have to supply? We have to supply with fuel. Okay, in the fuel you have to burn, and along with the fuel you have to also supply with air. Okay, air in the presence of which you will get fuel will be combustion, because you require oxygen or air for combustion. That thing we know. So what are the inputs to the boiler? Three inputs to the boiler: air, fuel and water. Very, very important. Please be careful and please be attentive in understanding this. Okay, three inputs to the boiler and one output from the boiler, which is the steam. Okay, this steam fellow will go to a steam turbine, and in the steam turbine this steam will expand. What will happen? Steam will expand. In the process of expanding, what do you mean by expansion of steam? Steam expansion means steam is rotating the turbine. In the process of rotating the turbine, what happens to the pressure? Pressure will drop in the turbine, because the steam is impinging the blades of turbine and it will be dropping the pressure in the blades, because the blades are now rotating. Understood? So according to universal gas constant, PV is equal to gamma. Pressure and volume are inversely proportional. If pressure drops, volume will increases. So that is the reason why always we represent a steam turbine in this fashion. So this is the standard diagram for a steam turbine. This means that at the inlet, if you are having some volume, by the time you go out, the volume will be rising. Why? Because there is a drop in pressure. Okay, so how much pressure will drop, sir? That is the question. I am giving you a question. How much pressure will drop in a steam turbine? Let me give you an example. So steam turbine means it should have some input and it should have some output, which is nothing but exhaust. Like your vehicles will be having exhaust silencer, isn't it? Let us say steam turbine is also having some silencer like this. Royal Enfield silencer, this kind of silencer is there. Let us say this is exhaust, and this is exhaust. And where is this exhaust connected to? This exhaust is in the atmosphere. Understood? This exhaust outside is what? Atmosphere. And what is the inlet to the steam turbine? Inlet to the steam turbine is from the boiler. Steam is the inlet to the steam turbine. So in the boiler, steam is generated at certain pressure. Let us say, for example, I am taking pressure is some 100 units. Okay, input the pressure is some 100 unit pressure is coming into the steam turbine. Understood? But the outlet, let us say exhaust, what is the exhaust connected to? Exhaust connected to the atmosphere, and let us say atmospheric pressure is some 10 units. Okay, atmosphere will naturally have some pressure, isn't it? 10 units. Now tell me, what is the difference pressure? Okay, what is the pressure difference finally available in the turbine? Here 100 units, at the exhaust 10 unit. In between, how much you are having? 90 unit of pressure is there. But actually in this boiler, how much you are producing? You are actually producing 100 unit. And how much coal you are using? You are using that much amount of coal, which is enough to produce 100 units. But actually, how much is which the turbine is rotating? The turbine is actually rotating with 90 unit pressure only. Then what happened to remaining 10? Dogs have taken away? No. So due to the presence of more high pressure on the exhaust side also, you are not able to use whatever the totally you are producing. Understood? Because of this exhaust only, you are not able to totally utilize the entire thermal energy that you have produced in the boiler, and that is why the turbine efficiency will be very less due to this factor. So now tell me, sir, what can we do? Okay, sir, now what can we do to improve this situation? What is the situation? Whereas I am supplying with 100 units of pressure, but actually 90 units of pressure is only being acting in the turbine. So remaining 10 are getting lost. So there are two things that I can do to overcome this problem. That is, since your exhaust is connected to atmosphere, let us say atmospheric pressure is some 10 units, it is constant. Atmosphere does not change now. One thing what I can do is, I can increase my input pressure. Let us say, instead of 100, if I am making my input pressure 1000, then what will happen to the effective pressure? Effective pressure would be 1000 minus 10, that would be 990. In 100 units, 10 units is a 10%. But in 1000 units, 10% is simply 1%. Isn't it? So, by increasing the input pressure, we may try to improve the efficiency. But do you think increasing the pressure is practically possible all the time? No. Why? Because to increase the pressure, you have to increase the boiler size, cost of the boiler will increase, maintenance of the boiler will increase, and to withstand that huge pressures, you should also have the piping systems or the conduit systems. Accordingly, the cost, the maintenance or the operation also becomes complex. So that is not practically possible always, because theoretically you may say we may reduce it to 1%, but it's not like that. The other thing what I can do is, the other way is, what if I can reduce the pressure at the exhaust? Let us say, instead of 10 units, some artificial means I will do, and using that, let us say I will maintain only 0.1 unit pressure. If 0.1 unit pressure is there, input is 100 units, what will be the effective total units? 99.9 units. Don't you think the efficiency is increased? Yes, turbine efficiency will increase, isn't it? So this is the actual procedure that we will follow. So what we will do is, we will connect the exhaust to a low pressure unit. Okay, we will connect the exhaust of the steam turbine to a low pressure unit or a low pressure device, which is called as condenser. So this is the output or the exhaust of the steam turbine. I am connecting this fellow to a condenser. So condenser is such a place in the thermal power station which has the least pressure less than atmospheric pressure. Understood? That is called as a condenser. Understood? That is the reason why we connect a condenser. Why? Because now you see, the output of the steam turbine is connected to condenser, and condenser is having low pressure than atmospheric pressure. So effective utilization of pressure will be high in the steam turbine, thereby you can increase the efficiency of the turbine. So that is the effect of condenser. And the process of taking out the steam from the turbine to the condenser, what I mean to say is, the process in which the steam is exhausted from the turbine to the condenser, okay, the transfer of steam from turbine to condenser is called as bleeding of turbine. Very important point. Okay, bleeding of turbine means removing of steam from the turbine and sending it to the condenser. So removal of steam from the turbine itself is called as bleeding of turbine. Okay sir, now what happens in condenser? As the name itself says, it will do some condensation process. What is condensation process? Conversion of gas into liquid. Now initially in the boiler, evaporation will take place because water will be evaporated, converted into steam. Okay, this steam will do some useful work, it will expand and it will come back to condenser. Steam is gaseous form. In condenser, steam will convert back into liquid, that is water. Understood? So once in the condenser, steam is converted back into water, what I will do is, I will use a pump. What I will use? I will use a very big pump. Okay, and the pumps used in the thermal power station, do you know the rating? They are rated in megawatts. You see, the power is produced from the thermal power station. Okay, the power produced from a thermal power station, and a greater portion of that power again has to be utilized back by the components of a thermal power station to make it run. So that is the reason why the overall efficiency also is very poor. Okay, so what this pump will do is, it will extract the water that has been formed in the condenser and it will supply it back to the water circuit, and we will try to recycle the water like this. Understood? So this cycle of evaporating the water, you taking work from the steam, condensing the steam, and again sending back to the boiler. So at this steam, what is happening? The water or the working fluid is nothing but the fluid which is circulating in a cycle. Here it is the water. Water is taking some heat energy. Water is catching some heat energy. In the steam turbine, it is losing a bit of some amount of heat energy has been lost. Again in the condenser, the remaining amount of total heat has been lost in the condenser. Okay, and again it went back to the boiler. So this cycle of gaining heat and losing heat, okay, gaining heat and losing heat, this entire cycle itself is popularly called as what is known as Rankine cycle. So this cycle is called as Rankine cycle. So that is the reason why you generally hear this popular question MCQ that thermal power station operate on a cycle called as a Rankine cycle. Thermal power station operation is based on Rankine cycle. Understood? So this is what called as Rankine cycle, and you rarely find explanation about this Rankine cycle in any textbook. And they may also ask you what is the efficiency of Rankine cycle. Efficiency of Rankine cycle will be around 32%. That is about the efficiency of Rankine cycle. And next thing is, when will the Rankine cycle efficiency will be maximum? When the heat losses are less. When the heat losses are less means in the summer seasons, okay. In summer time Rankine cycle will have more efficiency, and in rainy or winter seasons Rankine cycle efficiency will fall down. So these are other aspects you can just write down, I will not write on the board, okay. So this is about the Rankine cycle. And tell me where major amount of heat has been lost. In the condenser. So we can tell that in condenser major amount of heat loss take place. So sir, now we understood that the thermal power station efficiency is very poor. So how can we improve that? Don't you think there is a way? Yes, before understanding how to improve a thermal power station efficiency, you must understand what are such factors which are actually governing or affecting the efficiency of a thermal power station. So that is what we will discuss now, that is factors affecting efficiency of thermal power station. There are three main factors. By controlling such factors, you can try to control the efficiency, overall efficiency of a thermal power station. So the first factor is temperature of the steam. Next factor is pressure of steam. Third factor is pressure in condenser. So these are the three factors which will actually affect the efficiency, overall efficiency of a thermal power station. Now tell me sir, how should these parameters be in order to maximize the efficiency? In fact, temperature of the steam is directly proportional to the efficiency. That means if the temperature of the steam increases, efficiency, overall efficiency of a plant increases, and pressure of the steam also direct proportion to the efficiency. So more the pressure of the steam, more will be the overall efficiency. Now tell me about pressure in the condenser. It is inversely proportional to the overall efficiency. Lesser the pressure, more will be the efficiency. So in a pressure in a condenser must be less, but the pressure of the steam must be high to have the maximum overall efficiency. So these are the factors that actually affect the overall efficiency of any thermal power station. Now in this section what I will do is, I will try to classify thermal power stations based on usage, okay. That means the purpose of use. So basically thermal power stations are constructed in two purposes only, okay. The first purpose is called as commercial purpose, and next purpose is called as industrial plant. So you have commercial plants as well as industrial plants. Commercial plant means a thermal power station which is set up to do business. Do business means produce power to sell it. Understood? So obviously the ratings of commercial plants will be higher, whereas industrial plant is such a plant which is set up by some private industry to supply to his own unit. Let us say in some industrial area you are having some manufacturing unit. Let us say you are a car company and you are having a car manufacturing unit, and you are setting up your own thermal power station to supply your own power. You don't want to take the power from the utility. You want to create your own power and use it. So such a plant is called as industrial plant. Can you tell me what will be the rating of industrial plant as compared to a commercial plant? Very less. Industrial plants are small rating because they are set up for only one exclusive consumer. But whereas commercial plant itself for commercial operations, that is selling of power to various consumers. So obviously the rating of commercial plants will be high. So if this commercial plant is set up by governments, these plants also called as GENCO plants. Okay, GENCO plants are, I'm talking in general terms, this is not a standard terminology. In some states you call it GENCO plants like that. Okay, these GENCO plants, or that means generation corporations basically. These may be central government or state government. So that depends upon the next another thing. Okay. Next is, if commercial plant is set up by a private person, this becomes a very important question. Okay. Commercial plant set up by a private utility, a private person is called as captive power plants. This is a very, very important concept. Okay, if a commercial plant set up by a private person, it is called as a captive plant or captive power plant. For example, a Tata or a Birla or some Reliance has set up his own thermal power station, nuclear power station to supply power to sell the power. That is called as a captive power plant. But whereas if such a private fellow will set up a plant for his own purpose, then it is an industrial plant. Understood? Next, if we talk about ratings, power ratings, the rating of a commercial plant will be in the range of 10 megawatts to 1000 megawatts, or greater than 1000 megawatts also possible. Now when you talk about the rating of a industrial plant, it will be less than or equal to 10 megawatts. Okay, so that is the rating that is the rating of an industrial plant. And the steam pressure that we will use in a commercial plant will be in the range of 60 to 70 kg per centimeter square, whereas the pressures used in an industrial plant will be in the range of 1.4 to 7 kg per centimeter square. Next, when you talk about the steam temperature, the temperature here will range from 300 to 480 degrees centigrades, and here the temperature will be obviously less than 300 degrees temperature will be maintained. And when you talk about the type of alternator, we will use turbo alternator, whereas here we will use salient pole type alternator. So these are some differences between industrial plants and commercial plant. And there is another important difference, that is basically high capacity plants will have condenser to have more power generation or to have more efficiency. So this will be condensating type, and these will be non-condensating type. So condensating type means a power plant which is having a condenser. Non-condensating type means which does not have a condenser. And can you comment me about the efficiencies of both of them, whose will be high, whose will be less? Obviously the condensating type, and the one which is having high pressures, high temperatures, the efficiency will be high. So the practical efficiencies which I was telling belongs to the commercial plant, that is about 29 to 32% efficiency is possible in commercial plants, whereas industrial plants efficiency will be in the range of 10 to 20% only, because lack of condenser, that is no low pressure at the condenser, and small temperatures and pressures. So that is about condensating type and non-condensating type. And generally they say that if a plant is a non-condensating type, non-condensating type means there is no condenser. If there is no condenser, where will be the output steam from the turbine will go? It will release into the atmosphere. That means there is no recycling of water or condensing that steam back into water and supplying. So they say that if a plant is non-condensating type, continuous water supply is required. But whereas in a condensating type, water may be recycled, so continuous water not required. So they say that theoretically, but in fact it may be a condensating or non-condensating type, water is compulsory required at every point of time. Continuously water, maybe not continuously, but huge amount of water has to be available in case of condensating. But whereas for industrial plant, definitely continuous supply should be required to produce the power. But whereas here you require ample quantity of water, maybe after some time you can get the water, but continuous requirement is not there. Understood? So that is the difference between commercial plant and industrial plant. And this is like a bit of introduction to thermal power stations. So before ending the video, actually I want to discuss about another important technology that has been in use recently in thermal power stations. That technology is called as a supercritical technology, and the power plants using this technology are called as supercritical thermal power station. Supercritical thermal power station. What is the specialty, sir, of the supercritical thermal power station? The specialty is that the temperatures used in supercritical plants are in the range of 600 to 700 degrees centigrades, and the steam pressure that we use here is about 300 kg per centimeter square pressure. So whereas in normal conventional thermal power stations, the temperature was how much? It was around 300 to 480 degrees per centigrade. And what was the pressure like? Pressure was like 60 to 70 kg per centimeter square. Now you compare, where is 300 to 480, where is 600 to 700 degrees, where is 60 to 70, where is 300 kg per centimeter square pressure. So obviously the efficiency will also be high. What was the efficiency I told you for normal the conventional power station? It will be some 29 to 32% now. For critical power station, supercritical, the efficiency will range from 40 to 50%. Now latest plants which are being setting up in India, and most of the states right now in India are based on supercritical thermal power station. Example is there is a new plant setting up, going to be set up in Telangana state. It is called as Yadadri thermal power station, rating of 4000 megawatts. So this thermal power station also based on supercritical thermal power station. So there is another type of question that will be asked generally in competitive exam, that is highest rating of a steam generator unit. Highest rating of steam generator unit in India. That will be equal to 500 megawatts in India. So what does it actually mean? This means that steam generator unit means a generator alternator is one steam generator unit. We call it steam generator unit because it is coupled to a steam turbine, that's it. So a single unit of generator, what is the maximum rating? So single generator, one single generator maximum rating that is possible in India is 500 megawatts. But this is different from a rating of a plant. What is the rating of a power plant? Rating of power plant is a sum of continuous ratings of individual generators. So one individual generator maximum rating for a steam generator in India is 500 megawatts. So this is also an important MCQs generally asked in many competitive exams in India. Okay, thank you for watching.